continuing along, if we look at the next problem, problem A, 1 minus 3 over x minus 10 over x squared equals 0. Now, what we want to do is the same idea. We want to clear all the fractions. The quickest way to do that is to multiply by a common denominator of x squared. So we're going to multiply each and every piece on both sides of the equation by an x squared. Now, on the first one, that just means we're going to end up with x squared. On the second piece, we end up with a negative 3. Notice we multiplied by an x squared, which will cancel out one of the x's on the bottom with one of the x's we multiplied by, but we still have an x left over. On the last term here, we have our negative 10, but notice we multiplied by an x squared. That will actually get rid of the x squared that was on the bottom completely. So we're just left with the negative 10 equals what? Well, notice we have 0 times our x squared. Well, 0 times anything is just 0. So now notice what we have is a quadratic equation. How do we solve it? We factor. Well, how does this guy factor? Well, this guy factors as an x minus 5 and an x plus 2. Setting both equal to 0, x minus 5 equals 0. And x plus 2 equals 0, we get two answers. We get x equals 5 and x equals negative 2. Again, we still need to check to make sure both solutions actually work. Notice, the only thing that makes the denominators equal to 0 is if we were to actually plug in 0 for x. And we didn't get 0 for x as either one of our answers, so both of our answers will work because they will not make the denominators equal to 0. So both of our answers are valid and we can use them. Now for problem B, in order to get a common denominator so that we can get rid of all the denominators, we actually need to factor the denominators. So let's see, that first fraction, we can factor out an x on the denominator. So that will give us 4 over x times x minus 3. The second fraction is a difference of squares, so that will give us x minus 3 and x plus 3. And that's going to equal 0. Now that it's factored, though, we can talk about our common denominator, which is going to be an x, because that's what's in one of the denominators. Also, notice that we need to be able to cover an x minus 3, because each of the denominators has one of those. And I also have an x plus 3, so I need to have a common denominator of x minus 3 and x plus 3. So I'm going to multiply each and every piece here by an x plus 3, and an x minus 3. So an x minus 3, and an x plus 3. An x minus 3, and an x plus 3. Now technically I do have to worry about the other side, but it's a 0. So multiplying the 0 by, even if it's an x plus 3, and an x minus 3, is not going to change anything. It's going to stay the same. Because 0 times anything is 0. Now on the first fraction, notice what's going to happen is our x minus 3 that we multiplied by on the top and that we've got now on the top and the bottom will cancel out, and that x we already had, which will cancel out with the x we multiplied by, leaves us with, let's see, we now have left over a 4 and an x plus 3. So if we multiply out the 4 and the x plus 3, that will give me 4x plus 12. On the second fraction, notice quite a bit of this will cancel out. The x minus 3 cancels out from the top and the bottom, and the x plus 3 from the top and the bottom cancel out. Leaves me with just a negative x. Now on the other side, yes, we do have quite a bit of a mess, but it's 0 times that common denominator on the other side. Well, 0 times anything is 0, no matter how complicated it is. So now all I have to do is combine my like terms. Well, I've got a 4x and a negative x, which will give me 3x. We still have a plus 12 over here, and it equals 0. So solve this like a normal equation. Subtract 12 from both sides. That will give me negative 12. And then we'll divide both sides by 3, which gives me negative 4. Again, the only thing that I care about is that this did not make my denominator 0. So you can plug it in to both denominators, and in fact, it doesn't make either denominator 0, so it is a good, valid solution. The only things that actually did make our denominator 0 were anything that made the LCD 0, which is, well, if you look at it, what made the x 0 would be 0. What made the x minus 3 0 would be 3. And what made the x plus 3 0 would be a negative 3. As long as we're not getting 0, 3, or negative 3, we are all set, which is negative 4 is neither one of those, so we are all set.